Now that we've learned how to add and subtract matrices, we're going to work on our last operation, which is multiplying matrices. And notice that we are not introducing division because there is no division in matrices. So in multiplying matrices, we're going to discuss a number of terms that are important in matrices. Let's first of all take a look at when we can multiply matrices. Right off the bat, this is completely different than adding or subtracting matrices. When we added and subtracted matrices, the dimensions actually had to be exactly the same. That is not the case in multiplication. What has to happen in multiplication is when we want to multiply two matrices together, we need to basically start off by lining up their matrix dimensions side by side with each other. This is going to give us an inclination as to why, or as to if we can multiply the matrix. Now, you can see here, if we have matrix A and it's a m by n, let's just say it's a 3 by 2, for example. So I can just make up an example of this. So let's say that this is a 3 by 2 matrix. Let's say matrix A is a 3 by 2. And then matrix B, it's n times p, or n by p, excuse me. Let's just say that that is a, I don't know, a 2 by 3. Let's say it's the opposite. What we're going to actually do here is we're going to first off, we're going to check the middle dimensions. And so if this middle dimension in here is equal, then we know that we can go ahead and multiply these matrices. And what's going to happen is the resulting dimensions will actually be 3 by 3. Okay, and so you can see it generically here with the mn's and p's. You can see it here with numbers. Now, let's just take the same scenario and let's flip it around. Let's say we wanted to multiply b times a. This would give me a 2 by 3, and this would give me a 3 by 2. And you can see that our inside dimensions are the same, which means that we can multiply it, but notice that the new dimensions of b times a are actually 2 by 2. And so you can see here that this could actually create a completely different matrix whenever we flip around the order in which we multiply these matrices. So right off the bat, you should be starting to identify that the order in which you multiply matrices in is extremely important. And so be sure to not assume that you can just put them in any order and make the multiplication happen. So that's a very first important process and concept for you to understand. So let's take a look at example number 1. All we're asking you to do is to identify whether or not two matrices can be multiplied together or not. And so if we look here, part A, we have a 2 by 3 times a 3 by 4, and we can see that the 3 and the 3 are the same. So that means that our resulting matrix is going to be a 2 by 4. Okay. Now on part B, however, since the two inside, if I should better term, the two inside dimensions when side by side are not the same, then the product's not defined. It can't be multiplied together. And so that is extremely important for you to understand and to identify. On the second example, however, we do have a 2 by 2 times a 2 by 2, and so the resulting matrix should also be a 2 by 2 because we can see that these outside dimensions create a 2 by 2 matrix. So this checks off. This tells us that we can multiply them, and then we get the resulting matrix. Now let's talk about how we're going to do this. The way we're going to do this is we're going to take the first row and we're going to multiply it by the first column. So we're going to take the first number in the first row and multiply it times the first number in that column. Then we're going to take the second number in the row and multiply it times the second number in that column. And then once we do that, we're going to add those together to get the first row, first column. So if you think about it like this, we are taking row 1, row 2, column 1, column 2, and we're putting those together. And if we take the outside parts, if we take the rows from the first one, so the rows from the first one and the columns from the second one, we're going to get row 1, column 1, which is a combination of row 1 and column 1 of the second one, and that's going to give us our first little entry in the resulting matrix. So this is a situation where once you learn the pattern and you've done this enough times, this can go very quickly, but the first few times that you do it, it can be kind of confusing. So the first thing I need to really kind of do is identify is this is a 3 by 2 matrix multiplied by a 2 by 2 matrix. And you can see here that our inside dimensions are the same. Since those are equal, my result is going to be the outside dimension. So I should get a resulting 3 by 2 matrix. And so my answer for A times B equals this following matrix. Now, if you tried to reverse this, if you tried to do B times A, what you would have is you would have a 2 by 2 times a 3 by 2, and you can see clearly from that situation that that doesn't exist, so that is actually undefined. And so it's very important the order in which you multiply these matrices in, given the dimensions. Okay, so what I'd like you to do is go ahead and try sample problem number 2 actually on your own. So go ahead and pause the video and work on that part by yourself. Okay, so if I did this, A times B is going to give me a 2 by 2 times a 2 by 2. So my resulting answer should be a 2 by 2, and in this case you should have come up with that matrix. And if I reverse this process, B times A, it's still 2 by 2 times 2 by 2, so that means that we can have a matrix. But notice, it's not the same matrix. So here, we do not have a certain property in math that you need to be familiar with. In this case, it's the commutative property. So if we switch the multiplication around, it does not give us the same answer like it does in real numbers. So matrix operations have certain properties associated with them, but commutative is not one of them. So let's take a look at some other properties that do work for matrices. You can see that the associative property works. That's just a regrouping of 3 different matrices. The distributive property works in both ways, and the distributive property of scalar, or associative property of scalar multiplication also works. So go ahead and try that now. We see the resulting answer is a 2 by 2 matrix. Now, if you were doing order of operations, you could have either distributed this matrix across everything, or you could have simply added the 2 matrices first and then multiplied the 2 matrices together. Your calculator is actually going to handle that for you, or you could do it step by step. But notice that they're all 2 by 2 matrices, so the resulting matrix is a 2 by 2 matrix as well. Alright, so that's your introduction to multiplying matrices.